Today we're going to be looking at hypothesis testing for the difference between two means, and today our samples are going to be dependent samples. Dependent samples are when our subjects are going to be paired or matched in some way. So maybe we have some type of pre-post testing. Maybe at the beginning of the unit, the teacher will give you a pre-test, and then at the end of the unit, they'll give you a post-test. Then we would want to know the difference between those means. There could be maybe a before-after. Maybe it's a weight loss program. They weigh you before. You do maybe a 10-week program, and they weigh you after. So you're still that one subject, and you're paired with your before and your after data, or your pre-test and your post-test. Now, in order for us to do this, we have to use a different version of the t-test, and it employs the difference in values of the matched pairs. The different ways to state these hypotheses are listed below. We are still looking at the mean, but notice it's not mu sub 1 equals mu sub 2. All of our values are matched in some way. So we have mu sub, and it's capital D. Some people like to say the D stands for dependent. I like to say it's the mean for the difference. It's up to you how you want to look at that. But if your samples are dependent, when we state our hypotheses, it's mu sub, and that is a capital D there. Notice though we still have two-tailed, left-tailed, and right-tailed. But now we're just looking at those differences. So pre-test, post-test, before data, after data, things like that. So the mu sub D is the expected mean of the difference of the matched pairs. So again, that capital D could stand for difference, could also remind you that it's dependent samples. It's up to you how you want to look at that piece. The assumptions for the t-test: the sample or samples are random. The sample data are dependent. If our sample size or the sizes are less than 30, the population or populations must be approximately normally distributed. And again, these are our assumptions. These are things we get to assume. If we were the actual researchers, we would have to show that these conditions have been met. The procedure, this piece I wanted to put it in your notes for you. It is also found on page 509 in your textbook. It's in a blue box on page 509. So if you wanted to have that open, you're doing a practice problem instead of your note sheet, you sure could. It's all right there, or if you lose your note sheet. So step one, we're still going to state our hypotheses and identify our claim. We're still going to find critical values. It's a different version of the t-test, but it still is a t-test. So that means table F or inverse t. It's going to be up to you which method you choose. Step 3, we're going to compute our test value. Now the procedure for this, how much work you want to show on this, it's going to be up to you. I do want to show you the table setup for this just to keep things organized. And then how much work you show on this, that's going to be totally your call. You might end up doing a bunch of work in your calculator, and I will also show you how you can use a calculator program to do this as well. So you do have the procedure piece there. So I'm going to go ahead and skip to our sample problem, and we'll walk through that procedure tables, or excuse me, the step-by-step, the procedure. So if we take a little read through the question, go ahead and just take a minute and read through that. So now in this case, we're not having to figure out what mu sub 1 and mu sub 2 are. Our samples are not independent, they are dependent. We have the number of days missed before the program and the number of days missed after. So each one of these pairs represents one of the workers that were part of the samples. So that is the same worker before the program and then the same worker after the program. So now we state our hypotheses. We looked on that on the very first slide, the 3 different ways depending upon which type of test we have, left, right, or two-tail. We still have H sub 0 and H sub 1. Now the symbol though is mu with a capital D subscript. That null hypothesis, like we saw in the opening slide, it's still going to show that no difference piece, or the before after, there's no difference, the two are actually equal. Now what we want to show, writing H sub 1 can be a little bit tricky. We want to show that they miss fewer days after the program. So we want less sick days after. We want less sick days after. When we find that difference, remember, difference is subtraction. It's going to always be the before data minus the after data, or the pre-test minus the post-test, whatever it happens to be. So it's always going to be before minus after. If we want them to miss fewer days after, that before piece is going to be the larger value. They're going to miss more days before, and they're going to miss fewer days after. So the before data, that value, the sick days before, are going to be larger or bigger, more than the after piece. So if we do that subtraction, if we take a larger number minus a smaller number, that's going to result in a positive difference. So the before minus the after, before is more days, after is less days. So if I take a larger number minus a smaller number, that's going to be a positive value. Now to represent that, that means my difference has to be positive, which means my difference is larger than 0. So we have to think about it in terms of it being a difference, the before minus the after. We can't just see that they're trying to miss fewer days and throw a less than in that alternative. We have to always refer back to the difference. And that piece is probably what is going to take the most practice and the most getting used to for this particular test. Finding those critical values in step 2. We talked about this in the procedure table. It's still just a t-test, so either table F or inverse t if you have a TI-84 plus or better. Our alpha in this case is 0.05. We are right-tailed. And degrees of freedom, I know we didn't thoroughly go through that procedure table. If you look in step F, when we're looking at the test value and things, it has degrees of freedom is n-1. So n-1 in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. So 10 minus 1. So your degrees of freedom, it's just n-1. And remember, these are pairs, so there's not 20 data values, there's 10 pairs. So whichever way you choose, table F or inverse T on your calculator, it's up to you which you would like to use. Our critical value, it is a right-tailed test. Our critical value should come out to be 1.833. Now, finding the test value. If you write out the whole table and things, it looks like a lot of work. It probably is our most involved test value formula that we will come across. This is listed in your procedure table. We have x1, we're going to let that be the before, and x2 be the after. And I'm just going to relist those data values below. So we have a 2, 3, and then the after. The next column is labeled with our capital D, D for difference. And it's the difference, it's always x1 minus x2. So before minus after, pre-test minus post-test, whatever sample is collected first. And we go ahead through and we find those differences. So we just take the before minus the after, and we're going to record those differences here. If you notice in your procedure table, I have that summation, that sigma capital D at the bottom. I don't have room at the bottom of my screen, so I'm just going to write it to the side. Our summation, remember, sum means to add. So I want to add together the values in that column. And we should get a 7. Again, I just added the values together in that third column. The fourth and final column of our table is we take all those differences and we square them. So x sub 1 minus x sub 2, that quantity squared. So in other words, just all the values in that third column, we just go through and square them. So 1, 1, 9, 1, 1, 4, 4, 1, 0. And then if you look at the procedure that I had on your sheet, we see another summation of our D squared, and that comes out to be 23. Each of those pieces, those summations, those are what we're after in order to be able to find our test value. So how much work you want to show, how much of that table you want to show is completely up to you. These two summations is what we need to continue finding our test value. The next piece we need to find to continue finding our test value, capital D bar. The formula, we take the summation of capital D divided by n, which is our sample size, or in other words, how many pairs we have. So our total for capital D, our sum for capital D was 7. Our total number of data pairs, or each sample size, is 10. You can leave that as 7/10, or it does work out to be a really nice decimal. The other piece we need before we can find that test value is our standard deviation. So it is a sample standard deviation, and we put a subscript capital D. The formula for that piece, it is in the procedures that I listed out, but I'm just going to relist it here so we can see the pieces put in. Sample size times, we have our sum of D squared, and then we have the sum of D squared. I want to make sure I talk about those two pieces. We've seen similar things like that before. So the first piece we have our sample size, which is n. Then we see our capital sigma with D squared. That's that total from the fourth column. Minus, in this piece right here, I need the summation of D. So just the D, just my 7, and then I square it. So those two pieces mean two very different things. The denominator just dealing with our sample size, then everything is contained underneath that radical. If I go through, I do the computation piece, roughly we're getting 1.4. Now we do have all the pieces to now find our test value. So yes, at this point, we still have not finished off step number 3. Just trying to finish up a video for because I wasn't planning on being gone for the morning. So again, we have done quite a bit of work and we still have not found our actual test value. We found some pieces. Now we need to actually find our test value. That's our little lowercase t. So the formula for that, we have d bar, which we've already found, minus mu sub d, divided by s subcapital D, divided by the square root of n. So we had to find d bar and little s sub d before we could find our test value. All the other test values we found, we've never had to find extra pieces first. So this one's a little bit more involved. It does take a little more work. How much of that work you show out, how much of this table or things you show out, again, that's up to you. The end goal of the table is to get those two sums. So focusing on our test value, d bar was 7/10. Mu sub d, that's just what we're hypothesizing it to be, which is 0. S sub d was roughly 1.4. Square root, our n is 10. So approximately we get 1.581 for our test value. Now from there, the rest of the procedure is the same, how we decide to reject or not reject. If you need to draw up the picture, you sure can. Our our critical value is 1.833, right-tailed. Test value 1.581. We're going to not reject. The null hypothesis. The null hypothesis was not my claim, and I didn't reject it. So there's not enough evidence to support the claim that the workers missed fewer days after the program. So the piece that's probably, again, going to take the most getting used to, excuse me, is how we actually state our hypotheses with the mu sub d. You really have to think about what you are subtracting and what you want the end result to be. Is the before data needing to be larger than the after? Is the before data supposed to be smaller than the after? What is the difference going to represent? So when you do before minus after, are you going to be looking for a positive difference or a negative difference?
Call the office, please. Mr. Anderson.
And also with your test value, that's step 3, how much work you show, again, that's going to be your call. If you are going to use the formulas instead of the calculator shortcut, the calculator program, please make sure that you do show me all of these things on your test. Show me what you got for d-bar, show me what you got for your standard deviation, and then show me your test value. Show me all those pieces. Whether or not you show the table, that's going to be totally up to you and what you need to help you be accurate on this. The other piece with this is the confidence interval for the mean difference. And notice a lot of those same things that were in our test value formula. We have d bar and we have s sub d. So you would have to, for this, you'd also have to go through and find d bar and s sub d before you can actually find your confidence interval. So let's go ahead, and I want to go ahead and do a full hypothesis test again and then find a confidence interval so we can compare the two. So go ahead, take a minute, read through the question, and see if you can state the correct hypotheses. Now the hypotheses in this one are a little bit easier. We still have mu sub capital D equals 0 for the null hypothesis. And then mu sub capital D, and we just want to show that there was a change in attitude, not necessarily an increase or decrease, but just that there was a change. So we just need to show that it's something other than 0. The 0 in the null hypothesis represents no change, so not equal to 0 in the alternative would represent that there was a change. So that's my claim. Step number 2 are critical values. Alpha is at 0.05. We are two-tailed. And degrees of freedom, still just n minus 1. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 1 degrees of freedom again are at 9. Either table F or inverse T, totally your call on how you want to find these. We talked about those a couple classes ago with section 9.2 in our t-test for independent samples. The critical value plus or minus 2.262. Go ahead and take a minute here. See if you can find the correct D bar, S sub D, and then the T value. I'm going to go ahead and jot them down here. I'm going to jot them down here what they should be. And again, how much of the table you need to show or how little, that's going to be completely up to you. So go ahead and, again, take a minute, find D bar, S sub D, and then in turn find T. If it were me personally, I probably would not be writing out the whole table. Maybe write out the differences and then add them all up. Maybe square those differences, write those down and add them all up. It's up to you. Once you have your test value, go ahead and make your decision. We will not reject again. So once again, there is not enough evidence to support the claim that there was a change in attitude after watching the film. Now, along with this, we already have all the pieces we need for that 95% confidence interval. We have all the pieces. We have D bar and S sub D. We also actually already have T sub alpha over 2. We already have that piece also. So if we take a look at our formula, we start with d bar, which was 1/10, minus t sub alpha over 2. And then in the parentheses, we just have s sub d, which was approximately 1.8, divided by the square root of our sample size. Please note the symbol at the center of that interval is mu sub d. The other side then is the same, except for we add the t sub alpha over 2. So if we do a little computation, on the left side we get, and you can go ahead, take a minute, try this out, and come up with those two things.